Hey, I'm Neil Goose, by the way, and I'll get straight to the point. A month ago, I lost my dog in a car accident. That was such an unexpected and devastating and giant loss for my family and me, because all loved Pixel so much. Pixel is the name of my dog, and it's a little bit weird to me to pronounce it in English, but overall, like, we were grieving a lot, and I decided to make something for him using my coding skills, well, mostly for the people who loved him as much as I do. So I created a software that generates the beautiful memorial videos from the entire photo video library that we have with him and make it unique per every render. And I'm quite proud that I was finally able to make something really valuable for me and for the people who I love. And the video turned out to be really amazing. So I decided to share this experience and the way I built this video renderer. So maybe somebody can also use it, even though I sincerely hope you will never need to create this kind of videos. Never. So here is a small part of the video, and then I'll share how I was able to make this kind of generations. And in the end, I'll play the whole generated video. As you probably don't know, I'm working on my framework for a video production automation called Eframes, and it's literally built for something like that. It's using Rust language and SVGs to render the videos. Please don't be scared by neither of this, because SVGs are pretty declarative graphics format, and the Rust language used by Eframes is very simple. It's mostly lifetimes, async stuff and something like that. I'll show you how to use Eframes to do something like that. I've spent mostly 3 years working on it, and I'm actually happy that it was not really useless, even though I probably will spend better those time with my dog right now thinking, but reflecting too much is probably not the best thing for this video. And I'm kind of proud by the outcome of this video and how this framework actually behaves right now. So I want to share a little bit how to use it, and maybe it will be useful for you and you can do something amazing with it. So first of all, to create a video using Eframes, you need to make a Rust structure with all of the data you need to render the video. We generate basically everything from animations to the set of photos to the set of scenes and transitions between scenes here. But at the top level, you basically create your video, define some additional properties, define your audios, and the actual render function, which returns an SVG written right in the Rust code like this using proc macro. You can also write any Rust code block in square brackets to define any attributes, pass any Rust values into the attributes, or even write some expressions inside. The Rust blocks are kind of cool. And to fill in the actual content, we use the concept of scenes, which are basically filling the timeline one by one, transition one to another one, and every time they are generated and totally unique per every video. And here is the actually interesting part. I was trying to actually pay attention to any detail in this video and to put as much effort as I can. So even that background that you can see behind the photos is actually also randomly generated, and all of the motions, all of the dots will be totally unique per every video run. Here's how it works. This pattern was originally inspired by the PS5 background animation, but in a little bit simplified version. Basically, I asked an LLM to create something like that background, then iterate on this, and when it was finally something similar, I basically created the code that generates it. There is also a solid movement of the dots, which is defined as two basically separate animatable values. Here's how you define it using Eframes API quick animation. You specify that at a certain timestamp, the value should be animated from the value A to B using certain isn't function, which could be something like linear, like here, CSS like cubic Bezier animation, or spring physics. In this case, you can see that the pattern of movement is pretty repetitive, but it's okay because they are basically out of focus. It's a background, and when they move pretty slowly, you never notice that something is off with this point. And now on top of that background, we render the actual scenes one by one according to the actual implementation of the scene. But that's not even everything. The music playing in the video is also totally dynamic. You can basically pick any song and play it as a background. The video will be automatically scaled to the duration of the video, and not even everything. The animation will be synced with the original tempo of the song, which makes the animation kind of slower or faster according to the overall vibe of the song, which makes it more in sync and more connected and smooth. So basically I can use literally any song with this video, even something like this.
I've done too great for us.
So now we define a different set of scenes, and the scene definition is very similar to the video definition. You can define your audio that will be played during this specific thing, some overlapping settings if you want to transition between scenes. And here is the very simple scene definition, which basically randomly selects the photo on generation, on the creation of the scene, and then randomly chooses a direction and animates the photo moving from outside of the edge of the screen, staying for a little bit with subtle rotation movement, and then moving out of the screen. The animation is defined in a more manual way because we're using the dynamic tempo, dynamically generated timings, but overall it's the same API, just returns the value for the translate parameters and applies it to the certain SVG image. Nothing actually complicated. And this is how basically all of the things within this video works. For example, here is a more complicated scene which works as a parallax effect with the 2 layers of images, the background moving indefinitely, and then the main image moving and like stopping a little bit, which makes this kind of like nice parallax effect. But the implementation is literally saying we firstly select the random set of photos. Even the number of photos is random, like from 6 to 10 photos. And then we animate the main background conditionally one by moving the photos based on the amount of photos. And we move the background indefinitely using one linear animation. And then we apply the certain translate value to the SVG groups, and we're good to go. The animation is perfect. And here is my personally favorite scene. Here, the photo fades in, then stays for a little bit in the center, and then disappears using random spiral movement. And what's interesting about this scene that it's actually totally random. The whole spiral movement is also generated randomly. The funny part, and the most beautiful part, to be honest, is that it's using Fibonacci numbers. Yes, it's those numbers that you have always seen in all kind of the benchmarks, but never actually used. So the Fibonacci numbers are basically using the Fibonacci ratio, or the golden ratio as it's known. What it is, it's basically a perfect spiral movement ratio, which you can see even in nature, like for instance in snail shells or in a sunflower seeds patterns. So in this case, to actually use this for generating this animation, we manually create the transition for all of the 3 stages of this animation right in the render function. Basically, for every frame, we calculate the current radius and the angle of the spiral using the spiral logarithmic formula, and then using this get the actual translation coordinates, which we then use to translate certain image to that position, which make this perfect and randomly deviated spiral movement. If you're curious about things like that, and imagine not being curious, or you just want to learn or repeat some kind of math, I have a brilliant offer for you. This video is sponsored by Brilliant.org. It's an amazing learning platform with 1,000 different interactive lessons across all of the different topics like data science, programming, or math. They actually help you get smarter every day. And I tried few of their math courses, and I find the visual algebra course and calculus course to be really impressive. I thought that I genuinely know algebra from back in the days, but the way Brilliant makes you learn new things actually transformed my mind. I wish I could have done this back in school. Basically, instead of droning into the formulas or reading a lot of text, they enforce you to interact with the task, the content, and learn visually. Like in this video, right? We practically use the golden ratio formula, we practically use the polar coordinate system, and you will remember this forever. With Brilliant, you can learn things like that every single day, whenever you are using their mobile application or website. And Brilliant has an amazing offer for you. To get 30 days access to basically any course on a platform, you can use this link below, or the same link in the description, or this QR code, which will allow you to access basically any course for 30 days. Amazing deal, right? In addition to that, you'll get 20% off the annual premium subscription if you decide to. And it's never late to learn something new and become better. Did I make my first YouTube sponsorship integration? That is crazy. But actually, thanks a lot to the sponsorship, because I was grieving so much about my dog, but this requirement actually pulled me over because I've been not doing anything for weeks. So yeah, getting back to the other things. There are a few more different things that are defined in kind of similar ways, The first one is basically a heap appearing from every edge of the screen and forming like heap of the images, which looks really nice to me. There's another thing showing smaller photos. They're flying out from different edge of the screen and then developing using kind of Polaroid effect. What's interesting about this one, it's also rendering the year of the photo was taken using the EXIF data from the image. And it's kind of cool because if you upload basically any images, it automatically shows the year it was taken. And it's kind of like nice because you don't need to think about this. You can actually display something meaningful. There is also a dedicated scene to display some video. Basically, it also takes the random video from the set of the available videos. And then it uses fframes API to synchronize the frame from the video to the certain frame of the scene and gets the frame as an SVG image. I specifically love this feature because we're using ffmpeg's libav, basically C backend of ffmpeg to decode the videos, and we are reusing all of the memory with the decoder. And then we're basically getting pixels, well, bad joke, we're getting pixels from the decoder and using it as a native SVG image. In this case, if the video is vertical, which is well how the most doc videos are recorded, I added a blurred semi-translucent background of the same image to the background of the video to make it look more interesting. I especially like the way background dots are visible through that background filler, which makes it kind of like cosmic appearance or something like that. And basically that's all of the possible scenes. The timeline then constructed from the shuffled set of scenes. The scene's duration is also dynamic, and the last portion of the available time is filled with the final scenes, which have probably most complicated and most interesting looking animations. So the first animation is basically a line drawing the cuter version of the Minoc names of the pixel. This kind of animation is incredibly easy to make with SVGs. Firstly, you need to get the actual SVG of the text you want to animate this way. I used the online tool to convert the Google font to one big SVGs and pasted it directly to the fframes sync component. And then I added stroke dash array, which is basically defining how big dashes would be within a stroke, make them pretty big. Then animated the stroke dash offset, which makes it look like it basically drawing the line. The only important part that if you will try to do something like that, you need to use the thin fonts because we're animating the strokes and not the fills. You can see a few empty spots on the actual rendered path, but it's totally okay. Nobody noticed it until I mention. And the next animation happened within the final thing is basically another math beauty. We take all of that background bokeh dots, which you can see in the background, and then we animate their position to form a shape of heart. It looks kind of stunning. And at the same time, it's really nice because they're still doing this pseudo-random movement, but forming this 3D heart shape. The neat part here, that I didn't hard code all of these heart shape coordinates for every bokeh dot, because the number of dots are also randomly generated. And instead, I found the heart curve equation on some math website and wrote this simple function, which based on the number of total points, gives you the actual coordinate for every point to form the perfect shape of heart. And I find the code you can see on the screen absolutely beautiful. And that's basically it. Now you can use the preview app to get the real-time preview and test it out the way it generates the video, or you can render the final video file using one of the available rendering backends. You can use either CPU or GPU, and the CPU is still very fast. It's using my own fork of the SVG rendering library optimized for fframes specifically, and it can render and encode end-to-end this kind of video for 5x real time. But I mostly use GPU-based backend based on Skia and Vulkan or Metal, which is still kind of faster. I also made a very simple iOS application with one simple button to render the video, linked it with this actual binary from using Rust, and share it with my family using TestFlight so they can generate their own video every time they're grieving about Pixel using their own set of photos. Thank you so much for watching this video. I'm really glad that I was able to share this work with you. I would be glad if you will find it useful. You will find the source code in the description. You will need to sign for the beta right now. And I'm really glad I was able to a little bit celebrate my beloved doggo life with you. Give an extra hug for your pets from me today. Remember that they're not forever with you. And here is the final generated video as I promised.